Hi everyone, Queeveen here from the comfort of my kitchen. In today's video we are going to be taking a look at Titan, Saturn's largest moon. We may take a look at a couple of other moons as well, but Titan is reasonably visible at this time of the year. So you can see here, looking at around the middle of the month, the moon is pretty close to Saturn, so we're going to move a little bit closer to the end of the month. We can see that Saturn is nice and high here early in the morning, about 20 past 3, and Saturn is not quite at its highest, but we can see here as we push later in the night, Saturn doesn't quite reach its highest. We can see it vanishing there just before it reaches due south. And of course, once the glow of sunrise starts to come into the sky, using a telescope or binoculars to see anything in greater detail is going to be a little bit more difficult. But in true darkness, here we are 2:45 in the morning, much later in the month, about the 26th of July. And once we start taking a closer look, of course, we can notice Neptune immediately. So Neptune is visible there as a slightly bluish dot, but Neptune is, even under a lot of magnification, difficult to distinguish from a star. We can see Iapetus there being labelled, but if we hop through a couple of days, and if I remove the labels just to make things a little bit easier, there is Titan. So we can see Titan outside of Saturn as a separate object, even before we can see Saturn's rings. And we can see they're moving back in time. That increase in brightness, that's a sign that the moon is just out of view there. If we pull back a little bit, we should see the moon. There we go, a little bit less than full. But Titan is visible even with, well, I hesitate to say even with binoculars. Titan is certainly visible with a lower power telescope. Even if your telescope is too low a power to see Saturn's rings, Titan should still be visible. But with binoculars, it's difficult to see Titan, even if Titan is, there we go. So even though Titan is at the edge of Saturn there, it's barely visible here through binoculars. So we'll certainly have to go up through a telescope of some sort. Here we go. Even with quite a small telescope, too small to see Saturn's rings, we can certainly see Titan with the addition of a couple of extra lenses there. So Titan is visible distinct from Saturn, even if your telescope isn't powerful enough to see Saturn's rings, although this will vary on the day. So we can see Titan there on the 22nd, nice and far out from Saturn. There, the 22nd and the 23rd seem to be the best dates to see Titan. But once Titan is lining up with Saturn, either in front of it or behind it, then Titan certainly will be invisible with these lower magnifications. As we start zooming in and we start getting a view of some of Saturn's other moons, Titan's size becomes much more apparent. Titan is huge compared to these other moons of Saturn. But even more importantly, Titan is significantly brighter than these other moons of Saturn. If we zoom in here, we can see some of Saturn's other large moons. And if we click on Titan here, we can see it's magnitude 8. So it's certainly out of view to the naked eye, even though magnitude 8 reduced to magnitude 8.7, that is quite bright. If it was in a completely isolated part of the sky, it would regularly be visible with telescopes. But we're seeing Titan always right next to, here we have it at a 0.85 magnitude, this quite bright Saturn hovering around first magnitude compared to this practically 9th magnitude moon next to it. But we can see these other moons there, 9.79 for Rhea, another quite large moon. We can see Tethys there at 10, Dione at about 10, and we can see there Enceladus at 11.78. Enceladus is considered to be an icy moon, and you may remember from some previous videos, icy moons are considered some of the most likely to harbour life. If a moon has an icy shell on the outside, there's a good chance that volcanic activity, usually created by the gravitational pull of its parent planet, there's a good chance that some amount of volcanic activity is occurring under the shell of ice, thawing some of the ice into water. And water, of course, is one of the main things that we associate with life. Certainly all life that we've discovered here on Earth has a close relationship to water. Titan is different, and if we take a closer look at Titan, all we're going to see is this fluffy atmosphere, this thick atmosphere of methane and ethane clouds of methane and ethane being simple hydrocarbons, carbon with a few hydrogens stuck on the side. Underneath these clouds, the hydrocarbons, methane and ethane, rain down as liquid. They gather up in lakes, they flow as rivers, and they eventually evaporate again back up into these clouds. So Titan has a lot of hydrocarbons, and hydrocarbons are one of the building blocks of carbon-based life. Carbon is able to bond to multiple hydrogens, multiple oxygens. We don't know if Titan has any oxygen. It certainly doesn't have any atmospheric oxygen just floating around the place, but the amount of hydrocarbons that it has, it's made Titan a very interesting and potentially promising candidate for life in our solar system. All of the icy moons, like Enceladus around Saturn, like Callisto around Jupiter, these other icy moons that we see in the solar system, they're full of water, so we're expecting any life that we find living in that water to be reasonably similar to life on Earth, to use water as its primary solvent. Whereas on Titan, methane and ethane are the common liquids, liquid hydrocarbons down on the surface. If we find any life on Titan, it's more likely that it will use those liquid hydrocarbons as its solvent. Using a different solvent is a big difference in the way that life functions. We use water as a solvent for life here on Earth, so water is a very important part of the diet. We need to drink a lot of water to stay alive, and we generally find organisms living in places with some amount of water. Those life forms that can live in very dry areas, they very often hibernate or aestivate, depending on how you pronounce it. They go into a state of dormancy, a tun state in the case of tardigrades, if they get too dry or if things get too cold and all of the water freezes. If we find life that can use something like methane or ethane as a solvent instead, it brings up the possibility that life can be very different from the life that we expect here on Earth. Now, I've removed all of the labels, but we can see very bright Venus there, of course the moon with that orangey yellow glow because it's so close to sunrise. We're here on the 23rd of July, just about 4:30 in the morning. If we take a closer look at Jupiter, we're going to see Jupiter's moons. There's Callisto out at the side, these Jovian satellites. There's Io, of course, covered in volcanic activity. We don't expect to find much liquid water there, so of course not much life. We can see Ganymede here and Europa. Now we can also see that these moons are quite bright. They are a lot closer to us, of course, than moons that are orbiting Saturn, things like Dione and Rhea, but the iciness of these moons contributes to their brightness. Ice is very reflective, so it gives these moons a reasonably high albedo, and I don't think albedo is a factor that we see here on the side. So with the description of these moons, we don't see albedo as a factor, but many of these moons, everything except Io basically, they're all considered to be icy moons. They're all moons that have a shell of ice. Some of them show evidence of cryovolcanism, where liquid water is spurting out from their icy shells, which is of course a really good sign that they have liquid water under those icy shells. We almost certainly wouldn't see liquid water spurting out if there wasn't liquid water there to be compressed out of those ice fields. Saturn has an icy moon, Enceladus, and it also has this atmosphered moon, Titan. So Saturn in particular is an interesting possibility for the chances of life. Saturn has a much weaker electromagnetic field. The electromagnetic field of Jupiter is incredibly powerful. So the moons that exist within that field, those moons, Europa, Callisto, they're going to be bombarded by these high energy particles from the sun caught in that magnetic field. Saturn's magnetic field is weaker and it's further from the sun, so those things aren't as much of an issue. On Enceladus, it is an icy moon, so we can maybe expect life that uses water, whereas Titan, due to its methane-ethane atmosphere, if there is anything living on Titan, it will be living in a very different biosphere. and that is promising. It would be very interesting to find life on Titan, because it would show that life can be very different from the kind of life that we expect here on Earth, and it would broaden our options when it comes to looking for life in other places. If life survives on a planet like Earth and on a moon like Titan, well, that opens up multiple options for where life could exist elsewhere in the universe. So, I hope that you enjoyed this video, just talking a little bit about Titan and these moons and the potential for life existing on them, and the reason that it's important, why Titan is so interesting, because it is this very, very different moon. If there is a biosphere there, it would be very, very different. I hope that you enjoyed this video. If you did, please do like it. If you enjoyed this kind of content, then you can subscribe to this YouTube channel. You can also check out my website, queebeanscontent.ie, where you can find some of this information written down, and hopefully I'll see you back here next time.